Hello all, in this video we are going to see chlorination of well and the calculations using Horax apparatus. Few of my videos on problem focused only on formulas. Now in coming videos, I am going to focus on individual problems which are useful for undergraduate and postgraduate medical and nursing students. These problem videos focus on problems in epidemiology and statistics. These videos are not only important for your theory examinations, but also important for the understanding of the concepts which you can apply in your life. And also, these concepts and calculations will help you in practicals and also in competitive exams such as NEET, etc. etc. So in the upcoming videos, we will focus on individual problems and formulas in detail. So in this video, we are going to see about chlorination of well. In community medicine, for chlorination of well, we use an apparatus called Horax apparatus, which estimates the amount of bleaching powder required to disinfect the given sample of water. As a prerequisite, this video requires some basic knowledge about disinfection and the concept of chlorination. If you have that basic background knowledge, it will be very good to know. Otherwise, also, I will try to explain in between whatever the concepts of chlorination and concepts of this Horax apparatus necessary for the calculation of the problem related to this Horax apparatus. In this video, we are going to see about the purpose of Horax apparatus, the contents of Horax apparatus, the principles of Horax apparatus, and calculations involved in the Horax apparatus problems. That is what we are going to see in this video. Firstly, we focus on this purpose of Horax apparatus. As I mentioned earlier, the purpose of Horax apparatus is to estimate the amount of given sample of bleaching powder required to disinfect the given sample of water. When it comes to the concept of chlorination, we use here bleaching powder as the main source of chlorination. So bleaching powder is nothing but your chlorinated lime. So we have this bleaching powder here, and this bleaching powder releases or loses its chlorine content when it is exposed to humidity, air, sunlight, etc. etc. So as time goes on, the quality of bleaching powder also reduces. So the chlorine content in bleaching powder will reduce over time. So whatever bleaching powder we get in our hand will not have the maximum level of 33%. So 33% is the maximum level of chlorine which a bleaching powder can accommodate. So as time goes on, this chlorine percentage will goes down and it can reach up to 5%. If it is below 5%, there is no point in using that bleaching powder. The pungent odor present in the bleaching powder will reduce over time. So that indicates the chlorine amount is reducing. So we don't know the amount of chlorine present in the bleaching powder which we have in our. So that is a unknown factor here. The second unknown factor is the water which we are using for disinfection, because the amount of impurities and the amount of ammonia present in the water will absorb more amount of chlorine. Here we have two unknown parameters, that is the amount of chlorine present in the bleaching powder and the amount of impurities and ammonia required to neutralize the chlorine in the water. So we use this Horax apparatus, and this is the Horax apparatus. The purpose of Horax apparatus is to estimate the amount of given sample of bleaching powder required to disinfect the given sample of water. Now, what are all the contents of this Horax apparatus? We have one black cup which measures about 240 ml, which is present in the base of this picture. 6 white cups which carries 200 ml capacity. So these are the 6 white cups, and you should not confuse 6 black cup. You should not confuse yourself. Most people will write black cup and 1 white cup. So it is 6 white cup and 1 black cup. So we need to remember that first. And this black cup has the 240 ml capacity, and white cups has 200 ml capacity, and we have 7 stirring rods, one for the each cup. So far we have 7 cups and 7 stirring rods and 1 pipette in order to take the water from the bowl, and we have 2 metal spoons with 2 gram capacity each and 2 droppers. So these are all the contents of Horax apparatus. So here are the stirrers present, and here are the metal spoons present. And these are the indicator solutions and the start solution which we need to perform the Horax apparatus. Now, before going to the procedure and the calculations involved in Horax apparatus, we look at what are the principles of Horax apparatus. Basically, it contains potassium iodide indicator solution, starch solution, and sodium chloride solution. When we add chlorine to the water, after meeting the chlorine demand, that is, the chlorine gets neutralized with the impurities and the ammonia present in the water. Then after that time, the chlorine will appear in the water. That excess chlorine will combine potassium and iodine, which we add as an indicator solution in this Horax apparatus, will combine with the chlorine which is left free, along with the starch which is present in the indicator solution, will yield a blue color. We all know this process of identification of halogens, that is starch plus iodine plus indicator solution will give blue color. So that is the basic principle. So when we combine this potassium, iodine, starch, it will produce blue color. So the starch iodine solution will be prepared freshly. So for that we need 1.5 grams of starch in 100 ml of distilled water. We need to boil it, cool it, then 7.5 grams of cadmium iodide or potassium iodide need to be added for making the indicator solution. So the expiry date of this indicator solutions will be very less. So we need to prepare this indicator solution freshly in order to get correct results. When potassium, iodine and starch get combined, it will yield blue color. So that is the principle of Horax apparatus. Now we knew what is the purpose of Horax apparatus, what are all the contents of Horax apparatus, what is the principle of Horax apparatus. Now we are moving to the procedure of doing the Horax apparatus. First, we need to take the black cup and we need to take out the 6 white cups, 4, 5 and 6. Imagine these are all the white cups. So we need to prepare the stock solution with 2 gram of bleaching powder and distilled water in the black cup. Remember, this is not the water which we are going to test. We need to take distilled water that has the capacity, inner rim has the capacity of 240 ml. 240 ml. So we need to add the 2 gram of bleaching powder, which we are going to add for that situation. And remember, we cannot take some other bleaching powder and do this test. We need to take the bleaching powder, which we are supposed to add in that situation only, has to be added in the black cup, because different bleaching powder has different chlorine level and we will not attain the chlorine level in the water. So after doing this, we need to take 6 white cups. So we have taken that and we need to fill water in this 6 white cups. And remember, this water is the water which we need to test. So this is not distilled water. Here we have added distilled water and we need to use separate stirrers. As we told, we have 7 separate stirrers. So we need to put all the 7 stirrers here like this. Then after that, from the black cup, using the pipette, we need to take the supernatant solution. We need to discard the lime. Using the pipette, we need to take the supernatant solution and we need to put 1 drop here, 2 drops here in the second cup, 3 drops in third cup, 4 drops in fourth cup, 5 drops in fifth cup, 6 drops in 6th cup. So we need to add like that. Then we need to stir. With the help of the stirrers, we need to stir the water. Then we need to wait for 30 minutes. Then we need to add 3 drops of the freshly prepared indicator solution. So from this indicator solution, we need to mix these indicator solutions, and from that we need to add 3 drops each to this white cups. If suppose the third cup turns blue, from here onwards all the cups will be blue color. That indicates at this concentration the chlorine levels are adequate enough. And if the third cup turns blue, we need to add 6 grams of that particular bleaching powder to disinfect 455 liters of this given sample of water. If the fourth cup turns blue, then we need to add 8 grams of the given sample of bleaching powder to 455 liters of the given sample of the water. What is this 455 liters? How it has come is, this is a British based instrument, and this calculation is for 100 gallon. So 1 gallon is equal to approximately 4.55 liters. So this calculation is for 455 liters of water. So that is for the 100 gallons of water. So the third cup turns blue, we need to add 6 grams. So we are done with the concept of Horax apparatus. We are done with the purpose, principle, contents, procedure of Horax apparatus. And before doing the calculation, we need to calculate the volume of the well. In order to calculate the volume of the water present, here is the calculation of the volume of the water and volume of the water present in the well. And this calculation is done by the shape of the well. If it is a cylindrical well or the circular well, then you need to calculate with this formula, that is pi r square h. If it is a square or rectangular well, then you need to calculate with LBH, that is length into breadth into height. This is pi r square h, that is r is the radius, h is the height of the water level. And when we are incorporating the height, we should incorporate only the height of the water level, not the height of the entire well. So this is the height of the water level, and this is the breadth of the well, length of the well. And here it is r square. Sometimes people use for cylindrical wells, they can use pi d square h divided by 4. This formula also they will use. Instead of taking out the radius, people use this formula also. But I would prefer this radius one only in order to avoid the divisions in the end. Then theoretically, there is a most commonly conical well will not be present. Theoretically, if suppose conical wells are present, are given for the calculations, then you need to apply 1 by 3 pi r square h. That is, from the cylindrical well, we take out 1 by 1/3 of the pi r square h as the volume of the well. One important thing what we need to do here is, all the values will be given in meter as your calculation. So the volume arrived at will be in meter cube. So in order to convert this meter cube into liters, 1 meter cube is equal to 1000 liters of water. So whatever the meter cube which you get, we need to add with 1000 liters for calculation of the volume of the well. After getting the volume of the well, we apply the formula to calculate the amount of the bleaching powder required to disinfect the well. For that, from this formula, we would have calculated the volume of the well. So that we need to substitute here. That is the volume of the well. In liters, we need to substitute. And the number of cup which has changed the color. Suppose if it is third cup or fourth cup, we need to put the 3 value here. And we need to multiply it with 2. Then we need to divide it with 455 liter. Because this 6 grams is for, if suppose the third cup is turning blue, so this will give 6 grams. So this 6 grams is for 455 liters. For 1 liter, it is 6 by 455, and for 1 liter 6 by 455. When we multiply with this volume of water, you will get the amount of bleaching powder required to disinfect the well in grams. That we need to remember. If the value is too high, then you can convert it into kilogram. Anyway, we will work out one problem with the same formula. Now we have the problem here. Don't look at the answer which is present here. So just I am going to read the problem here and I am going to work out here. And finally, we will look at the answer here. The question is, calculate the quantity of given bleaching powder needed to disinfect 20-meter deep well, 6-meter diameter, 7-meter of water level. The Horax test done on the water sample indicates blue color in the 4th cup onwards. Write the steps involved in the chlorinating the well. So this will be your question. First, we need to calculate the amount of bleaching powder required to disinfect the well. Then you need to write the procedure to disinfect. As we all know, first we should calculate the volume of the well. So here it is cylindrical. So we need to calculate with pi. Here it is given in diameter. So we need to calculate. Our formula is by pi r square h is 22 divided by 7. R is the radius, which is diameter divided by 2, given 20 meter deep and 7 meter of water level. So R square is radius. So here given 6 meter is the diameter given. So we need to put the radius 22 into 7 into 3 into 3 into height. Here we should not get confused between this 20 meter deep and the 7 meter water level. What we need to take is the water level, that is the 7 meter only. So if we take this 7, so we get 198 meter cube, which again translate into 198,000, that is 198 liters of water. Then here the Horax apparatus turns blue color from 4th cup onwards. So we need to calculate the amount of bleaching powder required in grams is given by the formula 4 into, that is the number of cup which is turning blue, into 2 into the volume of the well 198,000 divided by 455. So if we work out this, we get 3481.31 grams. So we can convert this into 3.48 kilogram. So that is the required amount of bleaching powder required adequately to disinfect the given sample of water. So let us cross check this answer key here. So volume of the well calculated by the formula, we get 198 cube, that is 198,000 liters. So 4th cup is showing blue color. So 8 grams is required to disinfect 455. So for 1 liter, we need to add 455 grams of bleaching powder. 8 divided by 455 grams of water. So if we multiply it with the volume, you get 3.4 kg as the answer. Now, after calculating the amount of bleaching powder, we need to write the procedure to mix the bleaching powder in the well. The calculated amount of bleaching powder is made into paste in a bucket, and the amount of the bleaching powder should not exceed more than 100 grams at a single time. Then after that, 3/4 of the bucket is filled with water. And we need to wait for 10 minutes so that the calcium oxide and chloride separated, so the pre-chlorine will get released into the water. The supernatant clear chlorine solution transferred into another bucket. The lime which is present in the bottom of the bucket should be discarded and it should not be put inside the well, as it increases the hardness of the water. Then the second bucket which we took should be lowered and moved in all directions at different levels. That is, we need to move vertically and also laterally. The residual chlorine can be tested after 30 minutes with the orthotoluidine test. So here the orthotoluidine test purpose is to identify the amount of residual chlorine present in the water. So if we do the orthotoluidine test, we can identify the residual chlorine present in the water is adequate or not. Once this test indicates that the residual chlorine is present, then after 1 hour of contact period, after chlorination, you can advise the water to be consumed. Usually, this procedure has to be done every week, and during epidemics, every day this procedure need to be continued. That is, we need to test with the Horax apparatus. We need to add the bleaching powder to the well. Then we need to test with the orthotoluidine test. Then 1 hour of contact period, we can advise the people to consume the water. Horax apparatus is not available in your settings. Then there is a blind calculation for that. That is, you need to add 2.5 grams of bleaching powder, which you contain maximum amount of bleaching powder. That is 33% of bleaching powder for 100 liters of water. So if the bleaching powder is brand new, having the maximum amount of chlorine, then you can recommend 2.5 grams of bleaching powder in order to disinfect 1000 liters of water approximately. As the impurities are high, you can recommend the more amount of bleaching powder. So in this video, we have seen what is the purpose, principle, contents, procedure to calculation of amount of bleaching powder, and procedure to mix the given sample of bleaching powder in order to disinfect the given sample of water with the help of Horax apparatus. If you like this video and you find useful to you, please share it to your friends. Thanks for watching. If you haven't subscribed to the channel, please subscribe to the channel for the videos related to community medicine and research. Thanks for watching.